All right, so in this chapter, we are looking at the physical properties of solutions. And one thing that you may see in your textbook as you read is that chemists, scientists can often express concentrations of solutions in different various units. Some of those units are molarity, molality, percent by mass is also another concentration unit. And so here, what we're doing is we're calculating the mass percent, or you may see it called percent by weight. But here it's called the mass percent composition. It's fairly easy to do. So in order to determine percent by mass for a particular solute, because remember a solution in this chapter we're looking at properties of solutions, concentration units. We're determining percent by mass for a particular component. We have three components in this solution here. So the mass of your solute, these are my solutes. So I'm looking at diethyl ether. The mass of my solute would be whatever the mass of diethyl ether I have, and I'm going to divide that by its mass plus the mass of the solvent. That would be total mass of the entire solution. So solution is abbreviated SOLN. And then I'm going to multiply it by 100. Why am I going to multiply it by 100? Because a percentage literally means out of 100. Okay? So let's do these three examples here. So for component A, diethyl ether, let's do part A here. To find the percent by mass of this first component, I need to know what the mass of it is as a solute in this solution. It says a chemist mixes 39.5 grams of diethyl ether with this many grams of the second component and this many grams of the third component. We have a whole entire solution there. So I have 39.5 grams. How do I know that that's the solute? Well, it's the one present in the smallest amount. If I'm comparing this to the solution, I'm going to have more of the total solution, more solvent. So this is my solute, and I'm going to divide it by the total mass of the solution. And the total mass of the solution is going to be this plus this plus this. Okay? So the total mass of the solution, adding all of those components up, is going to be 153.9 grams. Now I'm going to caution you all, be careful, do not round this intermediate value. What you get here for a total mass of solution, after adding up the masses of all the components, which will equal the total mass of the solution, don't round it. Carry your decimal places. We won't round our intermediate values. We'll round when we get to the end to 3 significant digits. Okay? So all of this is going to be multiplied by 100, well, because it's a percentage. So if I take 39.5 and I divide it by 153.9, I get a decimal. But if I multiply that by 100, it comes out to 25.67%, and round it to 3 significant digits, it's 25.7%. Okay? Now again, this was times 100, so we could literally call this parts per 100. Let's say we were doing running a report, or we worked for a chemical company and we're doing an assay of water samples to test for pollutants, toxins. You're looking for things like maybe even at the part per million threshold. How could I make this parts per million? Well, if I multiply by 1,000,000 instead of 100, then I get parts per million. I can multiply by 1,000,000,000 instead of 100, and I would get parts per billion. I could even go to 1,000,000,000, and I get parts per trillion. So when you hear those things, this is what they're talking about, and this is how those are determined, those values. All right, so let's do part B. So for part A, we have that. For part B, let's look at the component we got. We have 4-methyl to 2-pentanone. Okay, so mass of solute 39.6 grams. We already determined the total mass to be 153.9 grams, and all of this is going to be multiplied by 100 because they want the percent by mass. Percent means out of 100. So 39.6 divided by 153.9 times 100 is 25.7%, rounded to 3 significant figures. And then part C is the last part. That would be the third component here. We have 74.8 grams is the mass of solute divided by a total mass of 153.9 grams. All of that multiplied by 100% to convert it to a percentage. So we have 74.8 divided by 153.9. We get times 100, we get 48.6%, rounded to 3 significant digits. So what we end up with is 25.7, 25.7, and 48.6. Now here's the thing that you want to check. These are our mass percentages for all of the components of this solution. If this solution is comprised of just these 3 components, then it should make sense that if I add up all of the totals of the mass percentages for each component, it should be 100% total. Let's check it and see. This is how we can check ourselves to see if we did it right. So 25.7 plus 25.7 plus 48.6 is 100% exactly. If we didn't get 100, that means that we rounded too much or too little, and we should probably go back and fix that so that we don't have any issues in ALEKS as we submit our final answers.